Dan Spots, on behalf of the Dallas Area Chamber, welcome to the Dallas community. Today is Thursday, February 12th. Our guest this morning is Wells Clark, who does everything technically challenging about the college,
I guess I can.
on my I'm going to ask. I'm going
Hello.
to get right to the chase here and ask people. I'll go around the table, ask for past introductions, okay? Because I'm having some issues up here. That's crazy. Sorry about that. Trish, go ahead.
Hi, I'm Trish Neil. I'm with Legal Shield, and we've just been named the best legal plan by Forbes 4 years in a row. And I'll drop my information into the chat. Thanks.
Thank you, Trish, and everybody. Please feel free to use the chat. We'll take questions anytime during the presentation here. Either raise your hand or put them in the chat box. Scott McKay.
Good morning, everyone. Scott McKay. I'm a volunteer for Circles of Care in the Dalles and also involved with the dementia-friendly Wasco County Partnership.
Thank you, Scott. And Misa Olson.
Hi, I'm Misa Olson, and I work for Vocational Rehabilitation as their workforce and business coordinator.
Thank you for joining us, Misa. Counselor Randall.
Good morning. Scott Randall, the Dallas City Council.
Thank you, sir. Mike Wacker.
Good morning, everybody. I'm involved with Fort Dallas Museum and the Dallas Kiwanis Club.
Thank you, Mike. All righty, Mike.
Good day.
Julie Reynolds. Julie Reynolds.
Julie Reynolds, Fort Dallas Museum Commission and the Historic St. Paul's Chapel.
Julie, I think you have an event coming up at the chapel here.
Oh, yeah, I should tell you about that. Well, Wasco County Historical Society. Wasco County Historical Society is having a meeting on it's History After Hours, and it's mostly for people who are associated with other local historical groups to come and find out what each other's group is doing. It's going to be on Friday the 13th, coming right up from 4 to 6 p.m. at the Historic Chapel. There'll be refreshments.
Excellent. We used to do something like that with Historic the Dalles Days. It's good to see that coming back. Thank you, Julie. Commissioner Brady.
Hi, Phil Brady, Wasco County Commissioner. That sounds really interesting, Jill. I'm sorry, I'm going to be out of town. Saturday night down in Shanicos is potluck, and I was listening to what people are preparing. It sounds really good.
Thank you. Thank you, Phil. And Jacob Anderson.
Good morning, everyone. Jacob Anderson, City of the Dalles Economic Development Officer, and boy, was it a beautiful sunrise this morning.
It was indeed. And Sue Davis.
Good morning, Sue Davis, Columbia Gorge Community College Executive Director of Advancement, and I'm going to drop something in the chat that is going to be related to what Robert Wells Clark is going to talk to us about. And
Very good.
It's in relation to our event on the 20th.
Yes, indeed. Thank you. Thank you, Sue. Kristen Fix.
Good morning. I'm Kristen Fix. I'm the Business Services Program Manager with East Cascades Works.
All righty. Thank you. And Leslie Naramore.
Morning, everyone. Sorry I don't have my camera on this morning because I am on my phone and nobody needs to see my face that close up. But I'm Leslie Naramore. I am the Executive Director of Mid-Columbia Community Action Council. And I did want to share just one quick update, and that is that we are now hosting Bread and Blessings on site at the Gloria Center. So if you've noticed that they are no longer downtown, it's because they are down at the Gloria Center. So they're Monday through Friday from 9 to 10, they're serving their community meals there.
Leslie, would you go ahead and put that information in the chat box as well, including the street address of the Gloria Center on 7th, just in case?
Sure.
Thank you, Leslie. And perfect timing, Roger Nichols. We're just concluding introductions, Roger. And while you get your speaker on, Roger, again, I'll apologize for everybody just staying off camera here, but my connection is having some issues this morning. I don't think I've missed anybody here. Roger, are you able to come off? Not yet. Roger, we'll go ahead and do there you go. Can we hear you?
Yes, thank you. I just got signed in. I had to put the garbage out. I forgot to do last night before the truck comes by this morning.
You got to do that.
That's the way it goes. Well, I just wanted to plug again in my affiliation with the original Wasco County Courthouse, who this Saturday got a fascinating program at 1:30 and it's free. This is Revive the Ride, bringing the Jansen Beach Carousel to the Dalles with David and Kristen Benko. Coming up the following week will be Dan Bolt, former Wasco County surveyor, on donation land claims. I'm doing one on the 28th about the other Mayor Mays. And on Saturday, March 7th, it's the Boys of 61 about the Grand Army of Republic, which is the veterans group for the Civil War Union side, which met in the Dalles several times during its existence. And also wanted to announce that we have recorded and dubbed all 165 previous programs. They're available for purchase, all the audio of this, and you can buy a thumb drive for $5 and a single program or up to 9 programs for $5 each, $4 for 10 or more, $3 for 25, $2 for 50, or all 165 for $1 a piece. So if you want to get your history in big doses, come on by. Thanks.
Awesome. Thank you, Roger.
Yeah.
Roger, would you also put a link to the series in the chat?
Okay.
Awesome. Thank you. Thank you.
I uploaded the program for the month.
Oh, I see it there. Thank you, Trish. Very good. And Leslie, thank you for the information on bread and blessings as well. With that, I think we're ready to turn it over to our speaker, our guest this morning, Robert Wells Clark, Columbia Gorge Community College. Robert, take it away, sir.
Good morning, everybody. So my name is Robert Wells Clark. I'm one of the instructors. There are 3 of us here in the Advanced Manufacturing and Fabrication Department at the college. This is a really exciting time for us. I'm excited to talk to you all. I want this to be conversational, so if you do have a question at any point during my talk, and I have a tendency to get really nerdy and talk about stuff maybe like at a level that is interesting to me, but might not be interesting to you if you don't understand. So please stop me. And I would be very happy to explain it further. If you see where we might be able to collaborate together or something like that, I would be happy to hear about that as well. But I want to tell you a little bit about our program. I appreciate Sue already plugging our event that comes up just about a week away from today. So a week and a day away. We have our new lab opening. And that's really exciting event for us. It's been a huge undertaking to get that done. And I'll explain a little bit of the context about that as well as I talk here. So this program was started about 8 years ago. It actually predates the Skill Center. We started out as just fabrication here at the college. Initially, we were more to support the electromechanical technology program. So they wanted those students to have some welding skills. So we started out of that welding skills. The classes were very popular, and we've grown into now we are offering 3 separate one-year certificates and 3 associate arts degrees as well. So 3 AAS degrees. Things really sort of took off with the building of the Skill Center, which Dan, of course, was a huge part of, and many others, of course, in the community. But when the program was selected to move into the Skill Center alongside of our wonderful construction technology program, that really kickstarted things. And we started to apply for grants in order to fill out the building with equipment. And we've always had a model where we want to, as best we can, serve our community, not just with workforce development, but also with real services and connecting our students directly to local employers in as effective and as efficient of a way as possible. So for us, that means that we try to develop as robust of a network with our local businesses as possible, many of them members of the chamber, of course. And as we develop that, we ask them not just, hey, are the students that we're producing what you need in your workforce needs, but also how can we help you grow your business? We focused in on a model that even before we had fancy equipment, we focused really, really tightly in on a model with some of our early partners of anything that they would be moving outside of the gorge. So if they were outsourcing any kind of fabrication or cutting or small component making to other areas of the country or to Portland, we wanted our students to have the opportunity to do that for them, as well as if they had a job that was too big for them. So one example would be one of our local partners was moving to a larger facility. And while they were moving all of their equipment, they had production that they couldn't keep up with because their machines were shut down. So our students were able to take that over. Another example was we worked with several years ago, we worked with Bulldog Welding. They took a big job with the Port of Portland and they needed some CNC cutting done to cut out the numbers that go on the side of pontoon boats. And they had looked at having them cut outside the gorge. But Jim Schraker came to us and we were able to have our students design, cut, and fabricate those small components for them to install onto their pontoon boats. The thing that really sort of kick-started us to where we are now tends to be a snowball effect, which is really cool. We applied for and received a $75,000 grant from Google to buy our first 2 machines. We purchased a couple of reductive process machines, so where we start with a block of aluminum and we carve it down into shape. So something like this part here, right? So this is a bracket, and this bracket starts out as one solid, just square bar of material, and we cut it down into the shape that we need. So we first bought a couple of machines like that after noticing that there was a definite workforce need in our area for that. Here's a sort of like, you can see where the material starts as this square like this, and then we use a variety of cutting tools to cut it down. So this part has another operation to cut it down, and then it will end up being much like this part as the finished product. That technology, frankly, is like, it's been around since the early 90s, and education has a real knack for being very reactive. And so the fact that we added this technology, in 2022, 2023, right, we're 30, 40 years behind what our local industry is already doing. And I just want to make sure that in the future, education is ahead of the curve, right? So we're proactive. So we're looking at what might happen next. We look at what trends are happening in manufacturing and how we can support development to better industry, not just support industry. And we think that one of those ways is through additive manufacturing. And so our most recent work is with metal parts and polymer parts in additive manufacturing. And our new lab is designed specifically to support that development and to make sure that we are able to provide support for regional manufacturers. Some of you might remember a business local to the Dallas called i3D MFG. They were an additive manufacturing house, one of the first ones in the United States, actually, that was producing metal parts. We're lucky to have a couple of former employees there when the business left the area to the Redmond area. We're lucky to have a couple of their former members that work for a large company called Electro-Optical Systems, which makes laser-based additive manufacturing equipment on our advisory board. And them, as well as many other people, have been very, very helpful in having us go down this path where we are now feeling a lot like we have the opportunity to be proactive and kind of get ahead of the curve and help transition some parts that traditionally would have been done in a reductive process to an additive process. So I want to talk a little bit about that. I want to talk a little bit about the different grants that we've done. I want to show you some photos and pictures of different work that our students and staff have worked with in our both community projects and public-public partnerships. So it's been a really exciting time. It's been one of the most stressful points of my career as well over the past months. I'm not in any way, shape, or form a construction person. So managing the construction project to get the lab built has been extremely difficult. And we are really excited to be able to be where we're at and be, for once, in education, proactive instead of reactive with where things have gone. I want to say specifically thank you to Dan Spatz, who really made some of the initial connections for us, particularly with additive. And we largely went down this path thanks to his guidance, his initial guidance. And he was at the time working for the college and was really such a great support along with so many others here. So thanks for the opportunity, Dan, and for really being one of the people that got all of this started in the first place, as well as your involvement with building of the Skills Center. So before I go on, I'm not able to monitor the chat or hands as well as I'd like. Does anybody have? Oh, I see 2 questions. So let's start with those. Go ahead, Commissioner Brady.
Thank you. Yeah, I've seen the work up there. I'm wondering, do you still have room in the lab for these great machines you're putting in? But my question is, how transferable are the skills that students learn here? For example, is it transferable to mass timber applications?
Mass timber specifically, probably not as much. So can you give me a little context around that?
Just that's another technology that I understand is on the horizon or is starting to be developed.
Yeah, absolutely. And well, that's like a wonderful technology. It's just we're not equipped for that piece of it, right? And the businesses that we work with aren't working with that piece. Do you know of local manufacturers that are working in mass timber?
Folks there's a major lab, I believe at Oregon State, and some companies that are associated with them, but I don't think there's anybody local.
Very cool. Yeah. I mean, I guess I would plug here that we are working with the Oregon State University School of Mechanical Engineering. So students that collect all 3 of our certificates. We have a 4th year. We're working right now towards applied baccalaureate. And that 4th year would transition them into the School of Mechanical Engineering at Oregon State. We work directly with Dr. Carl Hapla within the Oregon State University Industrial Training and Assessment Center. So they're our parent. And we do joint assessments of different manufacturers. So when there's a need for what we call a novel productivity enhancement, so like a fixture that might improve efficiency or something like that, we'll produce the prototyping for that small company and then collect the data on it. So I'll show you a couple examples of that just a bit later, but we're connected with initiatives like that. I think like we would be involved with or help with some of the widgets or the production pieces of that. But we wouldn't necessarily be involved in training people directly for the production of energy like that. Does that make sense? Good. Hi, Roger. How are you?
Great. I first met this gentleman some years ago when I did a story about him for the Ruralite, and he was handsome even then, so it's not fair. My question, you mentioned you showed us aluminum, but I'm assuming that you have all other metals. Are there any metals that you can't machine? I'm obviously uranium is probably one, but others that might be difficulty.
Yeah, so we can machine and print in a huge variety of different metals. This is a stainless steel 3D printed part. Because of the nature of the powder, it's very small and it moves through the machine for additive process specifically. We try to keep our machines running on a specific material for as long as possible since we have to exchange the filtration system and change things over quite a bit. The 3 main materials that we're going to focus on based on what our Industrial Advisory Board has talked to us about are ALSI 10 Mg, so it's essentially a 6 series alumina alloy. So 6061 aluminum would be the closest comparable. 316L stainless steel, because we do work with a number of sanitary grade applications. If you think about the brewing, winemaking, fluid transfer, and agriculture business in our area, those are huge components and huge parts of manufacturing. So food manufacturing and production. and processing are obviously huge in our area. So we do a lot of stainless steel work. And then we have a number of aerospace partners that we work with as well, obviously within in situ, and then the satellite companies, as well as Airbus now moving into the region after their acquisition of Aeroville. We will also be printing in TI-64, which is a grade 2.5 titanium. And so those sort of lighter weight materials are really popular. In terms of the machining side of things, it really depends. So the biggest thing is like we want to know what's in the material, and that determines how and what we use to cut it. So if we have a good grasp on what the material is, and if we have a certificate of conformity, we're able to pretty well adjust for it. We have one machine that we have dedicated specifically for different materials, so that when we create the chips, we can recycle them without having them intermixed. Is a big thing as well. The biggest thing is that we don't want to put something in our machine that we don't know what it is. For example, you can use cutting processes on magnesium. Magnesium obviously is a flammable metal, but your process needs to be very different. The things that you use to cut it are very different. The coolant that you use to wash it away is very different as well. Like you put water on a magnesium fire, right? That's going to be a big problem. So knowing what it is, and we can usually adjust and set up for it in the reductive processes, to give the machine a good clean down before and afterwards as well. But it is totally dependent. A huge majority of the work is in aluminum. Aluminum is really friendly material for students to use. We do a good bit of plastic as well. So we have like HPDE or UHMW plastics that we cut for local places. US water makers frequently has parts that are made out of plastic. Plastics is sort of not fun to machine. It like expands and contracts a whole lot. And so as we work with it and as we machine it, we want to make sure that we are hitting the tolerances necessary. And again, it requires different setup, process, and procedure. And so we think about that a lot. But the biggest thing for sure is knowing what we're doing, right? So the print that we get from the manufacturer or that our students produce, right, is going to give us a whole lot of information. So,
Robert, I see that Julie has her hand up also.
yes, yeah, I will get there. Sorry, I warned you all in advance. I was going to get into the weeds, right? So we frequently will have, I don't know, this is going to show up, my camera is pretty dirty, but we frequently will get a spec sheet print like this, right? And we're working towards the tolerances that are on that specification sheet, and we're having our students produce those tolerances as well. So what material we use, how we set up the machines, how we run the machines, all of that it comes back to what the engineer has designed or what the student has designed and how it's structurally been put together. So that was probably more than you bargained for, but it's a very contextual answer. All right, Julie, I didn't forget about you. I'm sorry.
No, I didn't. I knew you were going on. It was really interesting stuff. What happens? I mean, you have a lot of offcut and waste. Can you do something with that, or what happens to the
What a
fire?
great transition question. I'm so glad you asked. It's like my favorite question to answer. So you opened a can of worms. So when we take a part like this that I showed you earlier, we reduce the mass of it on a typical aerospace part by up to 85%. And that mass reduction, when we do reductive processes like this, it turns into really small chips. I'm here in a clean lab, in our metrology lab, where we have a temperature controlled environment and a $80,000 tape measure to check our tolerances and things like that. So I don't have any of these things in here. But imagine if most people have seen a chainsaw or chopped wood with a hatchet, and you can see like that waste that comes off. That's essentially the same thing that's created when we mill metal parts, right? So we get what we call chip. And that chip is then, we have to drive it to Portland. We take it to Pacific shredders usually. And then we get, cents on the dollar of what we've paid for it. It then goes into a smelter. It gets melted back down. The aluminum plant here in town is a place it's like a circular chain for us. Like we get Thunder Bar from the aluminum plant. We turn it back into chip. We take it to Portland. Portland sends it to the aluminum plant in the Dalles, which then turns it into Thunder Bar, which we buy from our supplier, right? And so it's a recycling process. One of our big grants right now that's focused on additive is through the Department of Energy Office of Supply Chains. And the reason why the Department of Energy is interested in work like this is that there's been a huge number of research into additive parts. So parts like this one that I showed you earlier, or parts like this one, essentially what we have is, if you can imagine metal flour, right? Like baking flour, but metal, it's about the same powdery consistency. What happens is and you'll be able to see this machine in action if you're able to come to our open house on the 20th from 5 to 7, and I would encourage you to. There is a recoater that sweeps this powder across the top of a metal platform, and one of our machines has a 400-watt laser, one of our machines has a 1,000-watt laser. That laser welds a 0.02 millimeter layer of that powder together. So we're creating parts dimensionally, 3-dimensionally in space as they come together, right? So that allows us to create flexible joints. So this is metal, and it rotates and floats around, which is really cool. So not only can we make geometry that's impossible, like there's no way that we could mill these fine little details out, right? This is just a fidget toy. It's really cool. But this webbing on the outside of this exhaust manifold runner increases the surface area of this and diffuses the heat at a much greater level. Like if you think about an old VW Bug, how the engine on it has all of the openings to cool it. Same concept, but we're able to do that in an efficient process. And to bring this full circle, when we're finished with the part, the powder that we use, that flour that we use, we have a very expensive and fancy vacuum. We vacuum the powder up. We run it through a sieve to clean it in case any metal chunks have fallen off or anything like that. And then we put it right back into the machine. So we have about 0.5% of waste of raw material. And we've been using the same powder for our stainless operations for over a year, right? We have very careful storage and procedure protocols for it. But we've been using that same powder for over a year, and it's still viable, useful, and we're still making parts with it right today, right? Whereas the aluminum that we buy, as soon as you make one part with it, that's the part that you get out of it and you throw it out, right? And it has to go to be recycled and smelted back down. So while it's more intensive upfront, the energy cost upfront, we're not remanufacturing the material, which is wasteful hundreds of times to make parts. We're not remining the material from the ground, which is wasteful to make parts. And that 85% reduction in mass now doesn't matter nearly as much because we are able to reproduce a part as often as possible. I want to go back to this part really quick. This is really quite a simple part, right? I can't tell you necessarily entirely what it is because there's an NDA related to it that I read before I showed it and talked to the people beforehand, but this is a heat exchanger. The reason that we did this with the printer was, and we did a case study for the Department of Energy on this part. The reason that we did this part with the powder laser machine is because it would have cost us about $800 in tooling and a block of 316 stainless about this big to produce the part. When we did the cost offset analysis, right, and we weighed the amount, we checked the mass that the part would weigh when we were done, we checked the amount of gas that we'd use, the amount of electricity we would use, and the amount of filtration percentage that we would use in order to produce the part, it ended up costing $285 to produce this part using the additive process and then to run the reductive process over the top of it to finish it to tolerance. And so it's saving the manufacturer $500 per part. There's 12 of these parts in an assembly. And very, very quickly, you start running into a situation where you're able to afford the capital equipment in production to produce the part this way instead of in an alternative manner. So there are good and bad parts for these processes, just like anything else, right? You just think about like using the right screwdriver to screw something in. You want the right tool, and then you want to see how those tools work together as well. And one of the things that we're really excited about doing is now we have really full spectrum capabilities within our stuff here at the college. And so we do a lot of like, hey, you're making this part in a traditional reductive process or casting process. Here is how you could do it right here in the Dalles or in Wasco County or in the Gorge. And here's what it would cost you long term. And so if you're interested, we'll produce a prototype for you and do a cost analysis for you, as well as if you have a new part. Like, for example, this geometry on this thing, there's no way that you make that in any other way, right? So this is all knotted together, and there isn't another process that makes it easy to produce that part, right? So not only is it exciting from like a cost perspective for manufacturers, my personal view on it as well is that it ends up saving a lot of energy, and the carbon cost of it is a lot less too. It's one of those rare things where I feel like it's a true sort of win-win in manufacturing. So we like to try to do what we call near net shape, where we get close to the size and then we still put in the reductive machine to finish the tolerance. That's kind of the weakness of additive manufacturing. But for automotive parts, they can come out of the machine and go straight into service. So does that fully answer your question more than you ever hoped for?
Robert, I've got a question, but I'm going to turn it over to Phil first.
Yes, that sounds good. Thank you.
I know it's hard. It's really hard to trim down a good response, and it's fine to give us the full explanation. With regard to additive manufacturing, is there applications for laminates where you have one layer of one material on top of another, and can you do that? And would you want to do that?
Yes, absolutely. Again, great transition. Thank you. So we work with, we're just starting work now that we have our new lab. We're starting work with Oregon State through their Industrial Training and Assessment Center. Also, we're working towards partnering with Oregon Manufacturing Innovation Center. And then there's a new sort of more nationwide initiative called America Makes. America Makes has a research and development center at Oregon State, and we're hoping to be part of the workforce development wing of America Makes as we move forward. So America Makes is through the National Institute of Standards and Technology, who we've had 2 previous research grants with, appropriation research grants with, that helped us buy our first additive machine, metal additive machine, as well as some polymer additive machines and supportive equipment. Where I'm going with this is that the research teams at Oregon State are going to work directly with our students in our additive program, and we will be working with projects like that where we have different material composites that are put together, right? A laser is a laser. We're able to tell the laser with the code how much power to use and where to shoot. And so there's no reason why we can't stop mid-build, change material, bond materials together. For example, tool steel and stainless steel work together perfectly well within the machine. I didn't even need to change the filter. I can just change the powder, and then that geometry, right? We can have multiple layers of different types of materials as we go together, or we can mix materials for a transition area, right? So you can have different mix the powders together, right? So that you have an area of transition from one material to another material. There are a lot of different ways, and the researchers at Oregon State are looking into advanced alloying, essentially using processes like this, where there's not a traditional method of alloying those together. We would be more on the operations side of it. So how do we set up and operate this? How do we make this work? Oregon State is doing the research, but it's a very collaborative relationship, which is really positive to have. It took me a long time to find true collaboration with four-year institutions. Generally, I feel like when they look at community colleges, they look at us as sort of like either competitive to what they're doing or as like little brother that's just kind of doing stuff. But you talk to the right people. Once we started talking to the right people, it was really a wonderful relationship. Just yesterday, one of our staff, one of our instructors, Lindsay Hegeman, was in Harrisburg with the Oregon State assessment team for their ITAC, right? So we're also an ITAC, but they're sort of our parent ITAC. And we participate in their assessments as often as possible, not only to learn their processes, but also so that we can add things to, if we see an opportunity for a novel productivity enhancement or a widget that might improve process at a manufacturer, we do that. the ITAC at Oregon State mostly focuses on energy efficiency. So as an example, like if you insulate this ducting or put a VFD on your compressor, here's how much electricity you're going to save over the course of the year. We're more focused on the production side of things and the prototyping side of things. So it's a great relationship. Yes, laminates are certainly possible. Obviously, we do polymer plastic parts as well with the laser processes, with the additive manufacturing laser processes. So even in those things, you can use different types of materials. Like there's a material called TPU, which is very flexible. And we can print those like a TPU joint within a nylon socket. And that allows flexibility with the rigidity of the nylon afterwards. So tons of examples of that beyond just advanced alloying of metal materials that are the polymer side is certainly more advanced right now. And it's really interesting to see where the technology is going and where it's going to end up to. I need to plug my laptop and I kicked it with my foot. Sorry.
Robert, I've got one question, and then I also Julie, would you like to go ahead?
Well, I was just going to quickly ask, how large of projects can you do with the additive process?
So it depends. It depends on what the material is, right? So we have one machine online. I'm going to give you dimensions in millimeters and roughly translate them to inches. I learned everything in metric growing up. So our current metal machine that is right across the hallway over there that we're moving into our new lab is 250 millimeters by 250 millimeters on X and Y and 350 millimeters in Z. Now we can position parts across that in many different ways, right? You can get pretty creative. Like it doesn't need to be just laying flat or straight up and down. But that's roughly 12 inches by 12 inches by 13 and a half inches or 14 inches. So those, if it fits within that cube, it'll fit. In the coming weeks, we're purchasing a machine that's 400 by 400 by 450, which is quite large. So that's 16 by 16 by 16 and a half, 17. And I guess 17. And that machine will be our largest machine, and it'll be 1,000-watt laser instead of a 400-watt laser as well. So it'll be a little bit quicker, more efficient on production as well. But again, it totally depends, right? So plastic parts, our laser machines are a little bit smaller. Our fused deposition modeling machines, like a traditional 3D printer that you might think of and see on the shelf at the store. Ours are sometimes a little bit fancier, sometimes they're the same one. We have a much larger volume of one of those. So we have one of those that's 2,000 by 2,000 by 4,000. So like 3 foot by 3 foot-ish, yeah.
Robert? Robert, I've got, first off, I wanted to announce for anybody who isn't aware of it already, and congratulations to you. You have been recognized as Oregon's post-secondary professional of 2026 by the Oregon Association of Career and Technical Education. Good work. Well-deserved. Congratulations, Robert. And my question at a broader level, the Skills Center, everything that you're doing up there, what does that mean for the Columbia Gorge and the Pacific Northwest economy? You are doing some grand, wonderful things in partnership with industry and in driving our economy forward. And I know that you have to drop off at about 10 till, so I want to be sure that we have time for that question. And then also tell us a little bit more about the event coming up on the 20th, ITAC.
Yeah.
Good to see there.
Yeah, I also buzz through some pictures here really quick and share screen after I finish my answer. Firstly, thank you. It's an honor to even be considered for an award like that. That's not why you're a teacher, you know what I mean? But it's really nice to have hard work recognized, and I feel very, very honored. Broadly, I think we're focused on sort of 3 things. Like if we look at the broader regional economy, number 1, onshoring. So anything that's made overseas, we'd like to have it made here. And the closer to here, right here, it to me is really important, right? I think American manufacturing is in a tenuous spot, but we have we definitely have a huge opportunity as well. And when we look at what we do overseas, just because it's easier, I think that we've stagnated a lot in terms of investment. Like for me personally and professionally, making investments into modern equipment that either meets or exceeds the local industry standard has been a complete game changer. And I think that one of the things that we've heard a lot, Lindsay, Chris, and I, is that we're operating more like a startup than an academic institution. And I think that if we take that same methodology and we apply it to our manufacturers by giving them really solid empirical data without them having to buy $500,000 of equipment to find out whether it's worth it or not, if we can do that for them for free, that's going to give them the opportunity to, instead of sending those parts overseas to be fabricated or to be additively manufactured or whatever, right? If you can give them really solid ROI data and say, hey, here's the thing that you're going to make somewhere else, and here's what it costs us to make it. Here's what a machine costs, and in 2 years, you'll have paid for that machine by doing it here instead of shipping it out. That's a really powerful tool for them to use, and a really great leverage for production managers and floor operators to go to the CFO, COO, and go, here's the study that I have that the college did for us, right? And in turn, we have now a workforce development solution, right? So when they buy that machine, they're going to need someone to run it and operate it. And we have that piece of it ready, turnkey, ready to go, because we've trained the students and they've likely done the project that they're going to be hired to do. We've seen that with the reductive process side. One of my very favorite stories is we had a student here that we gave them a project that was for a manufacturer. This was before we really had this stuff codified and sort of more finalized, but we told them, hey, here's what it costs to buy this machine that she's running and making your part on that you're really happy with. Here's what someone with her skill set should make. Your return on investment is 3 years. And so when they graduated, they were hired, company bought the machine, and that's her job now, is what she was doing while she was in school. And so, you know, that's happened once in transparency in the 3 years that we've been really working hard at this work. But I think that stories like that are really inspiring and also a really great example of if you put yourself out there enough and you show what the equipment, the students, and the processes are capable of, it gives us an opportunity in the gorge to be really ahead of things. And economically, like when we think about additive manufacturing and the opportunities that exist, not just within like the kind of concept of you can make really cool stuff, but also if we really push the limit on looking at how we produce these parts and what the cost offset is. You know, like one of the things that we did is we've tuned our laser to use nitrogen instead of argon. So a tank of argon costs me $42. A tank of nitrogen costs me $18. And I can buy a nitrogen generation system to produce nitrogen on site. That's going to, you know, if a local company did that and they were producing additive parts, they look at the cost of the per part at a really basic level instead of doing the research into it. If we can provide them that data and explain that costing, right? Oh, all of a sudden that part that you're having produced overseas in a casting house for $40 a part, if you can do it at $20 a part and you're making 1,000 of them, it makes a lot of sense to onboard those processes. So the process engineering piece of it as well is huge for what we do. Did that answer everything, Dan? I got it on a tangent again.
I have to remember to take myself off mute. Sorry about that. That was perfect, Robert. The one thing I wanted to be sure we talked about the event on the 20th. What are people going to see? And when is that?
Yeah.
And what's that about?
Yeah, I'll give a quick tour here in just a second. But yeah, basically, we're having an open house. We're celebrating the completion of the construction project. It's about a $780,000 construction project for a variety of reasons. A very technical lab, even though it's a small space. We didn't build a new building even. It was just a renovation of a classroom into a class 1 lab environment where we can handle, like, when you have such small powders, some of you might be familiar with like when grain explodes. When you have such small powders, it can be flammable if somebody dumps it and lights a cigarette or something ridiculous. But we want to be really extra safe. So there's we have an explosion room I have to tell you that having the conversation with Dr. Lawson about why we needed to have a blast roof explosion room in our lab was really interesting. But we have an explosion room and we have some really special wiring and outlets. And then the floor has a copper underlayment for electrostatic discharge for fire prevention. So we're going to show off all of that stuff. There's going to be a really, really exceptionally cool giveaway that I don't want to spoil that every person that comes in the door will get. I cannot stress to you enough. Lindsay made this on one of our metal additive machines, and we're going to give one to everybody who comes. And it is a really cool. You want this thing. It will be very pretty to look at, if nothing else, but also it's very functional. So, we'll have food and beverages, light food and beverages available as well for folks to enjoy. We are going to talk about what we do. We're going to have students there, and we're going to have some of our industry partners there as well. We'll have much of our advisory board will be there to talk with people. And then we're hopeful that our field manager team from Michigan State will be there. Oregon State will definitely be there. Dr. Hapla, and there's an assessment the same day out here in the gorge, which is great. So he's going to have his assessment team with him too, which will be really cool to see all of them. We have a number of other partners that'll be there too. So we just want to fill the space up and show you all of the things that we do, from the really cutting edge stuff to the stuff that we've integrated over the last couple of years to the more basic welding and fabrication stuff that we still do on a daily basis as well, that we sort of started from. And it's going to be really informal and casual, and we want to just show you what we do, talk about it, and share. And honestly, for me, it's like a little bit of a celebration of getting a big piece of my life back and not having to work on this construction project anymore, than the thing's done and like ready. So for me, it's a celebration of like, I don't have to come in at 6:30 and leave at 6:30 every day anymore. Which is really exciting.
Fantastic, sir. Other questions for Robert Wells Clark at the college? Around the table? Robert, I think one of the biggest joys I ever had working at the college is working with you. And faculty like you, but you've come first to mind. The enthusiasm, the commitment, the talent, the knowledge base that you bring, and the ability to convey that to your students and engage those students. It comes across obviously in calls like this, but you are like this 110% of the time. When I bring a member of Congress up there, I didn't have to worry about it. Let me introduce you to Robert, and I can shut up and walk away because you took it from there. And college is so fortunate to have you up there, sir. Misa, you have your hand raised.
Yes, I just wanted to give a shout out both to Robert as well as you, Dan, for volunteering to help us out with our Career Readiness Expo that we're going to have in a couple weeks. Robert's going to be on the panel. Dan's going to be helping with mock interviews. So this just demonstrates, how community focused you guys are. And I just wanted to say thank you.
Misa, would you be sure to put information about that in the chat box?
Sure.
Awesome. Thank you, Misa. We're looking forward to it. Robert, I know you have to scramble before too long to get ready for your class, which starts here in a few minutes. Other questions for Robert? Robert, any closing remarks?
Yeah, I think like two things. Number one, we've worked with over the last year every single school in Hood River County's 4th and 5th graders. We worked with all of the 4th and 5th graders in Wasco, or in School District 21. We work with Duffer, Arlington, Glenwood, Trout Lake schools as well. Every Friday, we try to host our secondary partners. And I think one of the defining things in my career has been the vertical integration of these things. I taught high school at the Dallas High School for a long time with Phil. Hi, Phil. And it was wonderful. But the opportunity and access to resource that community colleges have is just a different level. And we want to make sure that we share that. And I think one of the things that I'm most proud of and that I'll lead you with is that if you ever drive by Chenoweth Elementary School, we designed, built, installed the playground, the new playground at Chenoweth Elementary School. And for me, that's like a capstone project that really, it's public, but it really encompasses everything that we can do and the service that we can give to our community as a community college, right? The playground components were modular and designed by our students. We had an engineer on our advisory board stamp and certify the plans. We turned those over to the principals at the school, and we made these cutout sheets for the 4th and 5th graders to design their dream playground because everything's modular and it all pasted together. The school as a whole voted and picked the winning design. Our students created blueprints and a bill of materials and list. We processed 27,000 pounds of steel and 4,000 pounds of aluminum into product. We powder coated and painted it, and we installed it over the summer. We had 6 different high school welding teams come on Fridays to weld on it, as well as our students. We had every 4th and 5th grader in the school got to weld one of the monkey bars together on the structure. So from Chenoweth, if you've ever seen a 4th grader in a welding helmet, it's the best thing you can ever see, especially lots of them. And then over the summer, we hired 2 of our students as foremen, and we hired 10 local high school students through the Career Connected Learning Navigating Grant that is put on by the state of Oregon to help us with the install. So truly a horizontal, vertical integration of our industrial advisory board, of our local secondary partners, and of the college, and all for a really, really great cause. So I just think if I'm going to leave you with something without showing any of the, I prepped all these pictures and things that we don't have time for, but if I'm going to leave you with something, I want you to know that we are not just focused on the research side of things. We are also focused on the human side of things, even though we didn't talk about it as much today, and that we really want to be a resource. I think last week we had Chenoweth Elementary was here with Lindsay, and they designed and modeled Mayan pyramids on a computer and 3D printed them so that they could take them home with them. And these kids are capable of so much more than we give them credit for. And when we connect them directly to manufacturing, it really moves the needle in where they can go with their career, and the understanding that the things that they get don't just appear, that they're made, and that the process behind those. I think that's been the most exciting thing for me in my career is really developing those relationships. And so what I'm asking of you, I guess, as we leave here is if you think of an opportunity that, as an example, Misa, I didn't know about that program, and I want to make sure that we have a really good connection there. You know what I mean? But if you see a way that there's a school group or something like that we can connect with and integrate with, we hold our Fridays open specifically to facilitate visits, groups, tours, and hands-on activities like that as often as we can. So think about ways that, maybe you don't need a metal 3D printed thing to make your efficiency better at your job, but maybe you do work with a group of kids after school that are interested in coming here and hanging out with us for a while. So thanks.
Robert, there's one connection that if it hasn't been made already, it will soon, and that's with replacement of the Hood River Bridge. I know there's some interest in partnering with the college on that one, so we want to be sure that connection happens.
Absolutely, yeah. I know we were gonna 3D print a model at some point for you, and I would still love to do that.
Okay, I think that now's the time to do it. The designs are coming together.
Awesome.
Everyone, our guest this morning, and fantastic, Robert, thank you. Robert Wells Clark, Columbia Gorge Community College. Remember the ITAC open house coming up February 20th, 5 to 7. Be sure to be there so you can receive whatever that secret thing is that Robert was talking about. Looking forward to it. With that,
I put my email in the chat as well. I'm going to sign off, but if you need to contact me, please don't hesitate. I think Sue will stay till the end of the call as well. So my email is in the chat, and thanks for letting me talk to you about nerdy stuff too.
Anytime, Robert, anytime. Thank you. With that, I do want to note a couple of chamber events coming up. business after hours is at the Rayland Hotel, 112 East 2nd, February 19th, 5 to 7 p.m. Wired with the Chamber has a new location. The next one coming up is going to be the 18th at the Coffee Shop, 7 to 9 a.m., 116 East 2nd Street. Our guest on Community Affairs next week, Dr. Carolyn Bernal from the school district. Find out everything coming up with the this year with the school district. Ribbon cutting, several of them. China Gorge, Thursday, February 17th, 12:15. That's at 1410 West 6th Street. Another one at Texas Green LLC, 312 East 3rd, February 26th. And we have a whole bunch of Valentine's Days coming up here. So start off with the 14th, of course, 6 p.m. at the Civic Auditorium, Valentine's Day comedy show. Many, many other events taking place. Check out the Chamber website for that. With that, I think that we missed early on Salvador from the Housing Authority. Salvador, do you have any updates from the Housing Authority for us this morning? There you go.
Currently, right now, we don't really have any more updates other than last week's updates. Still working on the same projects. It's slow going, but continue to keep moving forward. Honestly, we have so many projects currently right now that we're working on that it's we have to move like a slow train at the moment. But hopefully here soon we will be picking up on the home repair for Oregon. As I mentioned previously, there is 2 programs for the state of Oregon that we're doing, and they're both grants. We're trying to aim for 0 to 50% AMI in the area. So definitely for the low income people that would definitely not be able to afford fixing like a roof or something like that is the ones that we're going to be focusing on a little bit more. But yeah, that's pretty much all that we're currently working on right now that is slowly moving.
Looking forward to keeping in touch, Salvador. Thank you very much.
Yeah.
And then Sue at the college, Sue Davis. Any updates from you?
Oh gosh, I have I think let's leave it at the ITAC event for now. The college is turning 50 in 2027. I guess that's one thing, Dan, I'm going to reach out to you about because you have so much of that history. But yeah, I think for now we'll just go with the ITAC event on the 20th.
College is turning 50. That makes me feel really, really old because I remember the college turning 30 and we were doing some special events. Oh, that's incredible.
Knowledgeable, Dan, seasoned.
We'll be talking. We'll be talking.
Okay. Sounds great.
Everyone, we're closing in at the top of the hour. Are there any other upcoming things for the good of the order before we close off? If not, I'll give you like 30 seconds of your day back, and be sure to join us next week for Dr. Bernal from District 21. Everyone, thank you for joining us, and keep in touch. Have a good rest of the week. Bye now.